Hey, welcome back. Our next goal is to make sure that the calculate balance method does not accidentally double count outputs. More specifically, if the address has already made a transaction, the balance should start from the output for the address in that transaction. And then only outputs within that block and afterward can be added to the overall balance. Let's develop this with a new describe block in our tests. So in the wallet/index.test.js file, we have this calculate balance function. And then this group of tests where there are outputs for the wallet. Now we want to capture a situation where, in addition to all of this, there's also this case where the wallet has made a transaction. So our describe should say, and the wallet has made a transaction after it already received some of those outputs, which we're already capturing above. Cool. Let's track the recent transaction through a variable. We're going to call this recent transaction. Then before each following test, let's make sure that the wallet actually makes a transaction. And we're going to set the recent transaction variable to the result of wallet.createTransaction. So recent transaction is equal to wallet.createTransaction. To make a transaction, we need a recipient and an amount. So how about foo address as the recipient? Again, it can be anyone, and the amount, anything as well, as long as it's valid. So 30 works just fine. All right. And then we'll need to add this recent transaction to the blockchain as the data array within a block. We'll call blockchain.addBlock, and we're going to add a block consisting of data with an array that consists of this recent transaction. Cool. And I'll make sure to actually have the whole recent transaction variable within the data array. Nice. Now we can add a test. So we should say that it returns initially the output amount of this recent transaction. Overall, it returns the output of the recent transaction. After all, since the wallet has now made a transaction, well, its actual balance should be set to the remaining balance that was recorded as part of this transaction. So we'll expect that if we call wallet.calculateBalance, and then we pass in the chain contained within the local blockchain, so blockchain.chain, and then we're going to calculate for this wallet.public key. So the address is wallet.public key. Well, overall, this should equal the output specified in the recent transaction for this wallet. So the expected value is recent transaction.output map, and then whatever value is stored at the wallet.public key. All right, nice. Now the tests don't stop here. We still need to make sure that any outputs in the block with that recent transaction and afterward are still calculated as part of the balance. In other words, any new outputs are valid until, of course, the wallet makes another transaction. So let's describe this with an even deeper block now, with a describe that says, and there are outputs next to, so within the same block, and after, so in subsequent blocks, the recent transaction. Now there are two kinds of transactions to consider in this case. First, we have, again, a transaction in the same block, and then there's a transaction afterward. So let's make local variables that capture both pieces of information. First, we have let same block transaction, and then we have next block transaction. Cool. Then we'll set up the scenario in a before each block for both of these. So before each, we're going to assign some of these variables. Now we'll reassign the recent transaction variable, so that way there's a new transaction that can be recorded as the recent one. This will be pretty much the identical functionality that we have above, where we have a recipient. This one, let's call it the later foo address since it's coming a little later. And the amount, let's be a little more generous. How about 60? All right, cool. Now we're going to make a same block transaction. And this case is actually going to be pretty relevant and appear often. So it doesn't just happen when the transaction, or rather the same wallet, makes multiple transactions. And in that case, that wallet should use the same transaction instance over and over again to specify new recipients. But this is valid if there's a minor reward transaction, and that minor wallet happens to be doing a transaction in the same block. So that means a same block transaction is most relevant for a reward transaction. And this reward transaction is going to reward the wallet as the miner wallet. Cool. And now the idea is that we're going to add a block that consists of both this recent transaction and the same block transaction. So let's add a block with the blockchain.addBlock method. This has a data field that is an array, and this will consist of our recent transaction and the same block transaction. Cool. Now we get to the next block transaction, and this one should be created by a new wallet. So let's have next block transaction. And the reason we want a new wallet to create this transaction is that we want our local wallet to be the recipient of this, because we're testing the fact that the wallet can receive outputs in addition after its most recent transaction. So the recipient should be the local wallet.public key. And the amount, let's be super generous. After all, we're adding to our own wallet, so let's make the amount 75. Nice. And the final thing we need to do in this before each is actually add a block that consists of this transaction in a data array. Next block, transaction. So if you're reviewing, the wallet should create a transaction that's recent. So therefore the balance should be the remaining balance that's in this transaction. However, in the same block, there's a reward for that wallet. So it should also include this output as well. But then afterwards, it's receiving another transaction in a subsequent block. So it should also add this output total that it's getting as a result of the transaction. So overall, the output should equal its remaining balance from the first recent transaction, the mining reward from the same block transaction, and the receiving value from the next block transaction. So let's capture a test that acknowledges all of that. We're going to say it includes the output amounts in the returned balance. All right, nice. As usual, we're going to expect the result of a wallet.calculateBalance call. Let's call wallet.calculateBalance. We're going to pass in the chain that is the local blockchain.chain. Likewise, we have the address, which is the wallet.public key. All right. And then this should be equal to adding up all the transaction output map values for this wallet public key from above. So that starts first with the recent transaction. We'll go into the output map and then look at the value for the wallet.public key. We're going to do the same thing for the same block transaction. We'll go to the output map and then access the value for the wallet.public key. Finally, we need to add the value for the next block transaction, going into the output map and then accessing wallet.public key. So the overall balance for this wallet should be the addition of all of its receiving values in all of these transactions. All right, nice. So that completes quite a hefty chunk of code, but these are all the tests that we need to calculate a more accurate and actually the accurate balance for the wallet based on its recent transaction. So there's this test for the same block and next block transaction. And then we also have a test to straight up make sure that it only includes the output amount of the recent transaction to begin with. All right, once you have all of those changes down, go ahead to the command line and then fire npm run test, and let's see the output and check if we do indeed have some new red text in the command line. And as it goes, you're going to notice that, well, here are the dangers of our current implementation of Calculate Balance. Since it's using the entire blockchain history and not accounting for double counting of certain outputs, it's going to report a deceptively high balance for the wallet. Now, this would be exciting if you saw this yourself, but this is really bad because what if someone actually tries to make a transaction with this? It'd be inaccurate in the blockchain and people in the network would be frustrated. So let's make sure to implement the logic to get these passes, or rather these tests to pass. In the index.js file of the wallet, head to calculate balance. Now our strategy is going to be to keep track of a has conducted transaction boolean. So as the first line, we're going to have has conducted transaction. And by default, this is going to be false. But the idea is if we go through all the transactions in the blockchain history And if we find that the wallet has made a transaction by its input address in the transaction, then we're going to set has conducted transaction to true. And in that case, we're going to special case the logic to make sure that it only includes outputs within that transaction in the same block and after. Now, to make this easier, let's actually iterate through the blockchain in reverse. Rather than going from the first block after the genesis and up, we're going to go from the top down because it's more likely that the wallet has a recent transaction near the top of the list. So the last block in the chain is always chain.length -1. We're going to make sure that this breaks when as long as I is still greater than 0. In other words, we're going to run this loop. And we don't want it to run when I hits a minimum of 0 because of the fact that this is the genesis block and that does not consist of genesis data. We're going to decrement, so have I minus minus instead of I plus plus. And now we can add an if check in here for every transaction. If the transaction.input.address is equal to the given address, well, then we know that the wallet has made a transaction. So let's set has conducted transaction to true. And the idea is we want to stop adding outputs once has conducted transaction becomes true. So after this for loop for the transactions of the block data, we're going to have an if condition of if has conducted transaction. And if this is indeed set and true, well, then we're going to call the break keyword. And the effect of the break keyword is it stops the for loop from going and decrementing. So in other words, if the chain is 20 blocks long, for example, and we're at the third to last block, and the address is found to have made a transaction, we're going to call break, so that way we don't have to go through the rest of the 17 blocks. All right, now this is nearly there, but we have one more condition to check, and that's to actually return only the outputs total if indeed the wallet has conducted a transaction. So first up, we're going to have a turning expression that says return something in the true case if a wallet has conducted a transaction. And if they have, well, we want it to return the outputs total. Otherwise, we're going to do what we normally do and return the starting balance plus the outputs total. So notice that this is a one-line if check. If has conducted transaction is true, we're going to end up returning the outputs total, which will not include the starting balance. It'll only include everything from its most recent transaction, the outputs that are in the block, and after. Otherwise, we're going to go all the way to the starting balance plus all the outputs that we found in the blockchain history. And I believe this would actually look nice on one line. So sorry for pressing Command up real fast, but here we are all on one line, and there we go. So once this is saved, check back in the command line, and with that change, we should now have a fully green passing test suite again. Cool. So the balance are going to be accurate for wallets once they create transactions. There's going to be no more accidental double counting of outputs. Great. As the last thing, now that we have an accurate balance calculation, let's make sure that information is reachable via the API.